There is a third parameter that can affect the color, and that is brightness. Although we haven't shown it explicitly, the colors we have been working with in these examples so far are B100. So what about brightness? It's easy to think that color is an intrinsic property of a material. You might look at a shirt and say, that shirt is made out of green cloth. But the color we see as humans is a combination of three things: a sample, like the material the shirt is made out of, an illuminant, that's a lighting source, and an observer, that's us. We can't dig into all the details of how these three things interact with each other, but if you illuminate a white sheet of paper with a green lighting source, the paper will appear to be green. So the illuminant does affect what we see as the color of something. So when you talk about color of something, you are implying a lighting source. And when color spaces talk about colors, they do in fact specify a lighting source. One of those sources is named D65 because it is light that is similar to the light produced by the noonday sun and also produced by just about anything that is heated up to 6,500 degrees Kelvin. So if we have B100, what we are saying is that we have our illuminant on full brightness when we look at that green shirt. If we take the white piece of paper we used just a moment ago and look at it with the lights turned off, it appears to be black, of course. So you can see that brightness does affect how we perceive color. If we take the same piece of white paper and crank the illuminant down to 50%, what color will the sheet of paper appear to be? Here it gets tricky. In a dimly lit room, everything, including white sheets of paper, appear off color or grayish. But you might perceive the piece of paper as being white. It depends on a bunch of things, including just how dim the lighting is. In general, the eye, when there is enough light, with the help of the brain, sees the brightest thing in the scene as being white, and uses that to recalibrate the colors it sees in everything else. Just to see how difficult it can be to talk about color and to emphasize the role the observer has in the perception of color, look at this simple board of gray squares. Look at the square in the center, then look at the second one from the left in the top row. Which one is darker? The one at the top, right? Well, let's inspect them with the info tool. It will show us the RGB values for each square. We see that the RG and B values are all 120 for both the center square and the second square from the left in the top row. Both squares are the same color by the numbers. Now we take a piece of white paper with some square holes in it where the interesting squares are and slide it over all the squares. And now, even to our eyes, the squares appear to be the same color. No, this isn't some kind of sleight of hand that is changing the colors as the sheet of paper glides across the screen. You can do the same thing yourself with a thick sheet of white paper and a pair of scissors to make the holes in it and get the same effect. This is just the result of the observer, that is our eye brain, trying to figure out what white is. So yeah, we see that color is really complicated when you want to be precise about it. But let's get back to the B in HSB.